Greetings and welcome to the video introduction to Concept Guide 5 for Chemistry 221. This is going to be a big area, so this is another time to kind of button down the hatches, start studying hardcore. There's a lot of material coming at us fast and crazy right now, and you know I'm here to help you, so all you have to do is let me know. But I just want to kind of take that time and give you a heads up. This is going to be a crazy section. So Concept Guide 5 starts off by talking more about the types of reactions. We're going to get into solution stoichiometry, which is basically when you have a solution and you want to know how much to add. It goes back to our concepts of stoichiometry we looked at in the previous area. This is going to be now in terms of solutions. We can add just so many milliliters to give so many moles, stuff like that, which is really important. Oxidation numbers are also a part of this concept guide. Oxidation numbers are when we have electron transfer, and electron transfer reactions are actually incredibly important for higher order reactions. We'll see this throughout the year. It's important to know when a species is oxidized, when a species is reduced, stuff like that. We'll talk a lot more about redox numbers in Chem 223 as well. Also in this area, we're going to look at thermochemistry, which is basically chemistry of thermodynamics. Thermodynamics is nothing more than heat transfer, and we're going to see how chemists can use this idea to figure out how much energy is released, evolved, absorbed, stuff like that. Endothermic means that energy is going into the reaction, and exothermic means reactions are releasing energy. And generally, exothermic reactions are the ones we're going to study in this whole year. We're going to look at the idea of heat transferred in the quantity Q. All right, Q has a special relationship to what's called delta H, which is enthalpy. And an important equation from this area is Q equals mc delta T. M is the mass, delta T is the temperature change, and C is the specific heat capacity, which is a type of quantity for each type of chemical. It reflects how much heat can be absorbed before you see a temperature change in the substance. We'll talk about this, but it's important to know how to use Q equals mc delta T. It's useful for figuring out temperature inversion, stuff like that, temperature changes. Also in this area, we're going to look at the idea of Hess's law. Hess's law is when we can take the enthalpies of different reactions to combine them in an overall reaction. It's a very useful thing for chemists, especially when you get into reactions where a lot of work has not been done already. We'll also talk about things like the heat of formation, which is when you have 1 mole of product being created from reactants in their standard states. This is an important part of some of the concepts involved. And please remember that the heat capacity of water, which we'll study over and over this whole year, is 4.184 joules per gram degree Celsius or Kelvin. All right, that's a thing you should memorize in the back of your mind. All right, a lot of stuff, but you know I'm here to help, so all you have to do is just say hey, and I'll do my best to help you out, okay? Good luck in your study.